For nearly all of humanity's journey, the night sky has been our silent guide, leading us across continents and lighting the path ahead. The stars are woven into the very fabric of our civilization, as inseparable from our story as the land and the sea themselves. Yet now, that ancient sky is fading away. While the stars, nebulae, and the haunting remains of supernovae still burn brightly, few of us will ever gaze upon them as our ancestors once did, even though all it would take is a simple flick of a switch. Today, join me on a journey as we unravel how the night sky has shifted within our own lifetimes, and discover the profound effects that artificial light, both visible and invisible, has had on us, on the living world around us, and on the frontiers of scientific discovery. We'll uncover how even the best-intentioned green revolutions have sometimes made things worse. We'll see how we've created dazzling artificial constellations in our own orbit, and how even the age-old patterns of the stars themselves are shifting before our eyes. That's right. We're about to witness how our sky will transform in 1,000 years, 1,000,000, and even across the span of billions. Just like anything that shifts slowly over the years, we rarely notice the change until it's too late. But sometimes, those gradual shifts are revealed in a flash, just as they were during the 1994 Los Angeles earthquake. In the early hours of January 17th, a massive portion of the city's electrical grid went dark, exposing the true impact of decades of relentless light pollution in a single moment. So stunned were the residents as they fled their homes, many stopped in their tracks, gazing upward in wonder at the spectacle that had always been there, veiled by the glare of city lights. Some were so bewildered, they called the observatory to ask about the giant silvery cloud stretching across the sky. Sadly, even the sky you remember from your childhood, the one that sparked your first dreams beneath the stars, is no longer the sky above us today. From 2011 to 2022, average light pollution grew by 10% each year, which means the darkness has more than doubled in just over a decade. So, let's set off together to a place where true darkness reigns, on a crystal clear night, far removed from the glow of towns and cities, and lift our eyes to the heavens to truly grasp what we have lost before we dream of bringing it back. There's a clever little scale for measuring the quality of the night sky as seen by the naked eye. It's called the Bortle scale, and it ranges from 1 to 9. In the heart of the city, beneath the harshest artificial glow, you might count a mere 100 stars at best. That's a 9 on the Bortle scale. But as you venture farther from the city lights, the sky slowly unveils its wonders, until it becomes almost unrecognizable from what you saw before. As you drive out to the urban edge, the darkness deepens to Bortle 7. And now, on a clear night, you might catch a ghostly glimpse of the Orion Nebula, barely more than a fuzzy, glowing star. Under skies like these, even the clouds are eerily illuminated, glowing against the dark. Push beyond the city's grasp, into the tranquil countryside, and you'll find yourself under a Bortle 3 sky. And that's when the true majesty of the universe begins to reveal itself. Show your love for the stars by liking, sharing this video, sharing your thoughts in the comments, and subscribing to our channel. Let's protect the beauty of the night sky together. Messier objects 15, 4, 5, and 22, dazzling clusters of stars, are now visible to the naked eye. Andromeda shines with quiet clarity, and if you peer closely, you might even catch a faint glimmer of the Triangulum galaxy. These two distant galaxies, lying 2.5 to 2.7 million light-years away, are the farthest things our eyes can ever hope to see without aid. And what of that giant, silvery cloud that once left Los Angeles in awe? That is our own Milky Way, a ghostly river of light arcing across the heavens, home to over 100 billion stars. At last, after hours on the road, you find yourself beneath a Bortle 1 sky, a place where the night remains untouched, pure, and breathtaking. Where you once could count only 100 stars, now thousands blaze before your eyes. You might even struggle to pick out familiar constellations, as they are hidden in the overwhelming tapestry of this magnificent dark sky. If you're fortunate enough to call the southern hemisphere home, you'll be gazing straight toward the heart of our galaxy, and you might even witness the Milky Way casting faint shadows on the ground. But to my friends in the northern hemisphere, there's no need to envy. Our cosmic luck will flip as Earth sweeps to the opposite side of the galaxy. In just 120 million years, parts of the magnificent Orion complex can be seen from both hemispheres. A colossal 1,200 light-year-wide nursery for stars, featuring the Horsehead, Flame, and Orion nebulae. Just be sure to bring binoculars for the best view. The closest thing you'll see revealed under such perfect darkness isn't a star at all. It's interplanetary dust. Bathed in sunlight, this cosmic dust forms a faint band across the sky, known as zodiacal light, stretching from one horizon to the other, with a mysterious bright spot at its center called the Gegenschein, appearing directly opposite the sun's position, above the constellation Virgo. Like, share this video with everyone, comment your own night sky experiences, and don't forget to subscribe so we can spread the passion for cosmic discovery together. Sadly, those of us living in cities may never know the wonder of a true night sky, forever trapped beneath an endless artificial twilight. This doesn't just rob the heavens of their beauty, it can have strange, unexpected effects on us too. But how is it that just a handful of light bulbs can erase an entire galaxy from view? The answer is sky glow, that faint, ever-present haze of man-made light. Any light cast upwards passes through the atmosphere, scattering in all directions. The portion reflected back toward the ground, into our eyes or telescopes, is what we see as sky glow. This glow dramatically lowers the signal-to-noise ratio for any starlight reaching us, making it so much harder to see, to marvel, or to study the cosmos. You may have felt something like this on a foggy night drive. Maybe, in hopes of seeing more, you switched on your high beams. But with just a slight upward tilt, those lights illuminate the fog ahead, turning your field of view into a blinding white wall, hiding the road, and making everything even harder to see. To make matters worse, it's not just that our skies have grown brighter. Heartbreakingly, our very eyes are losing their ability to truly see in the dark whenever we venture outside. The human eye is a marvel, able to perceive brightness across a full 9 orders of magnitude. We owe this to the fact that we possess 2 distinct kinds of vision. The first is photopic vision. That's what you're using right now. Our vibrant, daytime color sight, powered by the cone cells in our eyes. The second is scotopic vision, an ultra-sensitive, monochrome night vision granted by our rod cells. It's this scotopic vision that lets us glimpse the faintest details scattered across the night sky. But modern lighting is steadily stripping away that gift, because to the human eye, not all light is created equal. In the past decade or so, the shift to energy-efficient LED lighting has pushed the spectrum of light pollution away from the orange glow of sodium lamps to the harsh blue-green tones of LEDs, and those are exactly the wavelengths our eyes are most sensitive to. These blue-green frequencies slow our eyes' ability to adapt to the darkness, or worse. They can wipe it out completely in just a few minutes. That's why you'll often find astronomers or night pilots relying on red lights or red goggles, doing everything they can to preserve their scotopic vision. To fully unlock our scotopic sight, we need to avoid almost all short wavelength light for at least half an hour. And that night vision can keep improving for up to 2 hours after. You might be wondering, if our eyes are so sensitive to the blue and LED lights, why don't we simply use less of it and cut down on light pollution? And you'd be absolutely right. We could. But here's the reality. We don't. LEDs are so much more energy efficient than sodium or filament bulbs that we actually save money and power, even when running them at much higher brightness. So, more often than not, that's exactly what we do. We crank the lights up even brighter, because we feel safer in spaces that are flooded with light. Even though, statistically, it does nothing to reduce our chances of becoming a crime victim. There's something else most people don't realize. Our eyes are home to special retinal cells that aren't for seeing at all. They exist to help set and regulate our body clock. These cells are also acutely sensitive to shorter wavelengths. That means artificial light, and LEDs most of all, don't just rob us of the night sky. They impact our bodies in ways far more serious than we might imagine. When our circadian rhythms are thrown out of sync by light, it disrupts the production of key hormones, including melatonin. Incredibly, this imbalance can unleash a cascade of changes throughout the body, fueling everything from metabolic and mood disorders to, in the most severe cases, cancer. While for us humans, there may be a small benefit to artificially lengthening our days, for the rest of the natural world, the story is almost entirely one of loss. Bright lights interfere with the biological clocks of wildlife too, disrupting when and how they sleep, migrate, reproduce, hunt, and even evolve over time. Almost every species that scientists have examined so far has been harmed by artificial lighting. Not just individual creatures, but entire populations as well. Researchers have studied everything from fish, birds, amphibians, insects, and invertebrates, to ecosystems buried hundreds of meters beneath the ocean's surface, and even trees. Deciduous trees, which should shed their leaves every year, can be fooled by city lights into keeping their foliage all year round, a strain that can eventually kill them. Fortunately, there are simple steps each of us can take, little changes that save us money and protect our health at the same time. The best thing you can do is to simply turn off lights you don't need, especially outdoor lighting and uplighting that spills into the sky. And when you're installing new lights or replacing old ones, look for low-power LEDs with a warmer color temperature, say 3000 K instead of the harsh 5000 K. If the night sky amazes you, show your support by liking, sharing with friends, commenting your thoughts below, and subscribing to make sure you never miss our future explorations. Well-designed lighting always comes with proper shielding, focusing light where it's needed and keeping as much as possible from spilling out into the night sky. But even if we escape the reach of ground-based light pollution, a new threat is now rising. An overwhelming wave of light coming to us from space itself. On October 4th, 1957, the Soviet Union launched Sputnik 1, the world's very first satellite to brave the cosmos. In the decades since, the number of satellites in orbit climbed steadily, rising by about 30 a year for 60 years, all the way up to 2017. But then, from 2018 onward, Elon Musk's SpaceX began something the world had never seen before. But before we dive into that, remember this. With so many eyes in the sky, your data, every detail someone might want to know about you, is out there, crisscrossing the internet, increasingly bouncing between communication satellites. And all that information is gold for companies. Data brokers are eager to buy and sell whatever scraps they can collect about you. Your name, address, preferences, every last bit. And anyone can purchase it, for good or for ill, no questions asked. Since 2018, SpaceX has launched close to 7,000 satellites into the void of space. Alongside them, a few dazzling tokens of human ambition have also been sent to drift among the stars. At this point, SpaceX has more than twice as many active satellites in low Earth orbit as every other country and company on the planet combined. I've seen some wild hockey stick graphs in my life, but this one shoots straight through the stratosphere. The vast majority of these new satellites have been placed in low Earth orbit, LEO, circling just 550 kilometers above our heads. The United Nations Office for Outer Space Affairs, UNOOSA, estimates that as many as 100,000 more satellites could be launched in the next decade. There are currently no regulations to limit the number of satellites that can be sent up, and most agreements about reducing light pollution are informal at best. These satellites in low Earth orbit are especially problematic for light pollution, adding to the ever-present sky glow and leaving bright streaks in both amateur and research astrophotography, sometimes ruining images entirely. Astrophotography often requires long exposures, sometimes several minutes, and during that time it's almost inevitable that a satellite will streak through the frame. Try looking at a photograph of the Horsehead Nebula. Within that ethereal beauty, the scene feels almost divided, as if the serenity of the cosmos has been interrupted. I too have felt a sense of astonishment when witnessing this in my own image of the Orion Nebula, captured through my own lens. It's easy to see how satellites affect visual astronomy. You can watch their trails sweep across the sky in real time. But these man-made constellations that power GPS, mobile communications, and satellite internet also operate in the radio spectrum, across megahertz and gigahertz frequencies, and these signals have the potential to interfere with scientific observations. Radio waves are remarkable. They slip through galaxies, star systems, interstellar clouds, and Earth's atmosphere alike, unveiling cosmic secrets that would otherwise remain forever hidden. It's all the more astonishing, then, that the radio waves from my own Wi-Fi router can barely make it through a few walls at home. Radio astronomy has been crucial for mapping the shape and spin of the Milky Way, discovering quasars and pulsars, and detecting organic molecules like cyanide, ammonia, water, and amino acids within interstellar gas clouds. It was a radio telescope in Ohio that captured the legendary WOW signal in 1977. Detected at 1420 megahertz, a frequency long thought to be the prime choice for interstellar communication by an alien civilization. This channel is protected from commercial use to keep it free from human interference. Still, scientists continue to debate whether the WOW signal was just terrestrial noise or a genuine message from beyond our world. But as we consider how our communications can interfere with astronomy, it's worth remembering that astronomy can also interfere with our communications. In 1978, Arno Penzias and Robert Wilson were awarded the Nobel Prize in Physics for discovering that the static in their antenna wasn't caused by pigeons, but by the cosmic microwave background. The faint, cooled afterglow of the universe's very first light. The discovery of that faint background hum in their Bell Labs antenna, and figuring out what caused it, all but cemented the Big Bang Theory as fact. And, in another serendipitous moment, the radio waves emitted by the supermassive black hole at the center of our galaxy, Sagittarius A, were detected precisely because they interfered with transoceanic phone calls. I love stories like these, because they show humanity at its most inventive, its most curious, and, in many ways, its most brilliant. Sometimes it just takes pausing in the middle of building new technologies to say, huh, that's odd. And, suddenly, the world opens up with new wonders. So much has been discovered in the radio wave spectrum, yet even deeper mysteries remain unsolved. That's why the Square Kilometer Array Observatory is being constructed in the most radio-quiet places on Earth, the most ambitious radio astronomy project in history. I don't say that lightly. This is truly the most ambitious project of its kind. Its goals are staggering. To peer back to the cosmic dawn and witness the birth of the first stars and galaxies. To challenge Einstein's general theory of relativity by detecting gravitational waves indirectly. To search for the origins of life. To hunt for evidence of extraterrestrial civilizations. And to understand how our galaxy and the entire universe are changing under the forces of entropy, gravity, and dark energy. But what does all that cosmic change actually look like to us, standing here on Earth? If you gaze up through a light-polluted sky, space seems motionless. So still, in fact, that you might imagine we're on a Truman Show-style set with stars pinned to a painted backdrop, instead of riding a planet hurtling through our galaxy. Yet beneath a truly dark sky, nothing feels fixed. You begin to sense our journey through space and time itself. Earth is spinning around the supermassive black hole at our galaxy's core at a mind-boggling 828,000 kilometers per hour. We're soaring away from the galactic plane, racing inward toward the center. Our perspective, and every object we can see, is in constant motion. If you love the night sky, please like, share this video, leave your thoughts in the comments, and don't forget to subscribe so you won't miss our next cosmic adventures. The images reconstructed from Gaia telescope data reveal that the night sky is anything but still. It is constantly shifting and evolving over time. 1,000 years from now, only the keenest astronomers will be able to spot the subtle differences between today's constellations and those of the future. Although, if we're lucky, we may witness the dramatic explosion of Betelgeuse as a supernova. But in about 10,000 years, we'll have a new North Star. Polaris will drift away from the celestial pole, to be replaced by Vega, a much brighter star. Let's take a closer look at the constellation Orion and its neighboring stars. Over the next 450,000 years, Orion's sword will shatter, and his mighty bow will vanish completely. Zooming out to the entire night sky, as our galaxy evolves over 4.5 million years, you'll see Orion lingering in the bottom right corner, a testament to how everything above us is constantly in motion. What this data can't tell us, though, is just how many more stars will go supernova, or how many more will be born in the darkness. We'll simply have to wait and see. And honestly, that would be so much easier if you just turn off those uplights. But over the next few billion years, the night sky will become so strange, so unrecognizable, that you'd be forgiven for thinking we'd ended up in an entirely different galaxy. And the truth is, we will. Right now, Andromeda covers just 3 degrees of our sky, about 6 times the width of the full moon. But it's accelerating toward us, and in about 5 billion years, it will collide with the Milky Way, becoming the sky itself. Galaxies are so impossibly diffuse that Andromeda and the Milky Way will likely pass straight through each other, almost without any real impact. But what truly seals our fate is what we can't see. The gravity that binds everything together, surrounding us like an invisible web. Over the next 5 to 10 billion years, our 2 galaxies will circle each other, stretching and tearing themselves apart, unleashing a spectacular burst of new star formation from their mingling gases, until the spirals dissolve into a single, enormous, elliptical mass. Unfortunately, you probably wouldn't witness any of this from Earth, because the extreme natural light pollution would be overwhelming. The sky itself would be ablaze. Our sun will have swelled into a massive red giant. 1 trillion years from now, the very last star will be born. After that, there will be nothing left for the universe but endless decay. The galaxies that once glimmered beyond our merged home will dim, grow faint, and finally slip beyond the limits of our observable universe. In 120 trillion years, all stars will be extinguished, and the night sky will fade to perfect blackness. As is so often the case in our complicated world, our actions carry consequences we never expected. Our night sky is changing in many ways. It has been hidden from us, but it is not lost. Towns, cities, and governments all around the world are beginning to recognize the problem, making changes to ordinances and laws to protect our skies and the wild things that live beneath them. Thank you for joining us on this journey across the cosmos. I hope what you've seen tonight inspires you to look up at the night sky, to rediscover those moments of peace, and to help protect the beauty that stretches above us all. It only takes a small change from each of us for the night sky to become magical again. Please share this video with your friends, family, and community to spread the love for the stars. And don't forget to subscribe to the channel so you won't miss any of our upcoming adventures. Once again, thank you from the bottom of our hearts to everyone who's working to protect the night sky. See you next time, beneath the sparkling stars.